So today we're going to do sequences. Now next class will be series. Today is sequences. A sequence of numbers is just a list of numbers that form a pattern. Now, before we get into how to create the equations for these sequences, let's take a look at this sequence right here. We have 1, 1/2, 1/3, 1/4, 1/5. Now, these are on the bright pink note page. Now, not only does each term have a value, but it also has a position number. Now, if I'm looking at this first term, 1, this is in position A1. What do you think 1/2? What position could we call that? What about 1/3? And so on. A to the 4th and A to the 5th. A sub 5. Now these are the position numbers, and each sequence term has a value as well. The value of A1 is 1. The value of A2 is 1/2. The value of A3 is 1/3, and so on. The sequence values are like our Y values. So this is Y1, Y2, Y3, Y4, and so on. What do you think the X values are? What do you think the X values are? If those are our Y values. The subscript number, right? So our X value for this first term is 1. The X value for the second term is 2, and so on. These are like our input numbers. So, what pattern do you recognize in this sequence?
It's getting smaller.
What relationship do you see between the term number, the position number, and the term's value?
Well, it's decreasing, but only the the denominator is increasing by 1, but the numerator is staying as 1.
Right.
I don't know how.
So if you look at that first position, that term is a 1. And the position is A1. The second term's value is 1/2. And the position is A2. What matches here? The denominator matches the term position, right? A sub 2, without even looking at the sequence, is going to have a value of 1/2 because that's our position. What is A sub 10 going to be? 1/10. The position number matches the denominator. So what could we say A sub n is? 1/n. This is our, what is called explicit equation for this sequence. We can find any term with this equation. If I said A sub 1 million, what would our term's value be? 1/1 million, exactly. So if we have A sub n is equal to 1/19, what is n? 19. And if we have n equals 5, then what is A sub n minus 1? Yes, 1/4. If we call A sub n our term we're trying to find, or current term, what do we call A sub n minus 1? Yes, this is our previous term. This is the term before the term we're trying to find. Before our nth term. So all of this is kind of like background knowledge, prior knowledge, so that we can create these equations. Now there's 2 types of sequences, okay, that we're going over today. An arithmetic sequence and a geometric sequence. There are two types of sequences, and then for each type, there are two types of equations we can create, a recursive equation or an explicit equation. Now, arithmetic sequences, does anyone know what type of sequences these are? What's happening from one term to the next in an arithmetic sequence? You're adding or subtracting. Yes. Add or subtract. Now, the recursive equation type formula is a sub n is equal to a sub n minus 1 plus d, where we just learned a sub n minus 1 is the what? Previous term. And d is the what is called common difference. It is just what you add or subtract by to get to the next term. Now, when we're writing the recursive equation, we also always need to state what the first term is. So not only would we write a sub n equals a sub n minus 1 plus d, but we also put a comma and write a sub 1 is equal to whatever our first term is. Now, the recursive equations always, how I remember it, rely, oh my God, how do you, is it two L's? How do you spell rely? R-E what? One L? Like that? That looks weird. Rely on the previous term. Really? Doesn't it look weird to you? That's weird to me. No?
I mean, you're probably going to relay.
Relay?
Yeah,
Maybe,
with the
maybe.
A.
Oh, yeah. Okay. So a recursive equation, you always rely on the previous term to know the current term. An explicit equation, on the other hand, you can find any term in your sequence, no matter if you know the previous one or not. The explicit equation is the more useful. Recursive is the easiest one to write, but explicit is a little bit more useful. Now, there are two ways for an arithmetic sequence that we can write the explicit equation. One is by writing a linear line, where m is the same thing as our common difference, and b, instead of being the y-intercept, you can think of it as what I like to call the zero term, or what a sub 0 is equal to. So what we'd have to do is go back and find the previous term. Now, sequences aren't linear lines. Sequences model linear lines. They have points along the linear line. So we can always find the sequence value, the sequent term's value, by using a model of a linear line. Okay, or you can memorize the explicit sequence formula. A sub n is equal to a sub 1 plus n minus 1 times d. Honestly, it's probably easier to remember the linear line than this formula, but whichever one you feel more comfortable with, you can use. Okay, so let's try it. I'm going to kind of skip this portion. Well, should I skip this portion? Let's not skip it. Let's just do it real quick. We're being asked to determine whether the sequence could be arithmetic, and if so, find the common first difference and then the next term. So, what's happening going from negative 10 to negative 4? Shashank. Going from it's fascinating that you can talk and listen at the same time. Negative 10 to negative 4. What are you doing?
Adding 6.
You're adding 6. There we are. What about negative 4 to 2?
6.
Good. There we go. 2 to 8. And 8 to 14. You need to make sure that you're having the exact same common difference each time. So our common difference here is 6. And what is the next term? 20. You just add 6. Now this next one, negative 2 to negative 5. What's happening? Minus 3. What about negative 5 to negative 11?
Minus 6.
Oh, negative 11 to negative 20.
Minus 9.
And negative 20 to negative 32.
It's 12.
So, do we have a common first difference?
No.
It is not arithmetic. No. It has a common what is called second difference, by the way. But we don't need to know that here. We just were asked, is it arithmetic? But it does have a common second difference. Okay. So now let's go ahead and try to actually create these equations. We have to find both for this. We have to find both the recursive and explicit equation. Before we can write these equations, what do we have to find?
The common difference.
Yes, that common difference there. So what are we doing going from 9 to 5?
Minus 4.
And 5 to 1.
Minus 4.
And 1 to negative 3.
Minus 4.
Good. So our common difference is,
Minus 4.
so my recursive equation, I start off always with writing a sub n is equal to a sub n minus 1. And then from that previous term, what do we do to get our current term?
Minus 4.
You subtract 4. And then you always have to state what the first term's value was, which is 9. This is our recursive equation. All I did there was use the formula from up above, right here, this formula. Explicit, I'm going to write it two ways. I'm going to write it using the explicit sequence equation, explicit sequence formula. A sub n is equal to a sub 1, which is what? Am I going too fast? What's a sub 1 in this problem?
Oh, 9.
9 plus n minus 1 times the common difference, which is what? Negative 4. This is the explicit equation we could create using the formula. Or you could write it as a linear line. Y equals mx plus b, but what is our m?
Negative 4.
Negative 4. And how do we find that b, that 0 term?
I think it's 9.
You have to find the 0 term by going one step backwards. Instead of subtracting 4, what do we do?
Add 4.
And you get?
13.
So we write 13 as our 0 term. And that is the linear line equation modeling this sequence.
That's kind of silly.
It's kind of silly.
Yeah.
So the next 3 terms, what is a sub 6?
Negative.
And a sub 7?
What?
The top one, just numbers
I
past.
thought some of the second question.
Good.
I'm so confused.
It took me a second, but
These are the next 3 terms.
I wasn't making a face, I was just
Yawning.
Okay. Can you do this on your own? Thumbs up. Would you like another example? Thumbs down.
Shashank will teach you.
You guys
What?
are
I
petering
know.
out. Thank you, you 7 people that showed me your thumbs.
And we loved you very
I
much.
know this.
All right.
know,
I
but
do
you
want to
said
point
that
out,
person we can help you.
On this next one, see how it says find the 12th term? Which equation, recursive or explicit, do you think is best to then find the 12th term? Explicit, yes, because if we were trying to use recursive, we would need to find the 6th term so that we could find the 7th term, so that we could find the 8th, the 9th, the 10th, the 11th, so that we can then finally know the 12th. Whereas explicit, I can just boom create it. All I need to know is the common difference, which is -6, I believe. And then I need to know the a sub 0 term, which I add 6 and get 26. And then what do I do to get the 12th term? Plug in 12 for x and I get negative. Good. Yes, -46. All I did was plug in 12 for x.
I sold it from my mom.
Oh. That's why it doesn't work.
Yeah, it's karma.
Okay, just a quick few examples about geometric, and then I'll release you to do what you need to do for today. Geometric, instead of adding and subtracting, what do you think geometric sequences do to get to the next term?
They multiply.
Multiply, not divide, just multiply, because you can turn any division into a multiplication. Say I was dividing by 6. How could that be multiplication instead?
Multiply by 1/6.
Multiply by 1/6. Good. So here, for my recursive rule for geometric, it's a sub n is equal to a sub n minus 1 times r, where r is what is called the common ratio. Technically, it's called the common ratio because what we do is we take one term and divide it by the previous term, creating a ratio. Now, the common ratio is just what you multiply by to get the next term. The explicit rule is a sub n is equal to a sub 1, meaning the first term. There should be a 1 there. A sub 1 times the common ratio raised to n minus 1. Again, geometric sequences model an exponential line, but they do not form an exponential line. We don't connect those sequence values. But we can find the sequence values by using an exponential equation. So let's try it. We'll try one. First, we need to find that common ratio. How do we do it?
We divide one of them by the number before. So
Yes.
20 divided by 4.
Right. All you have to do is take one term and divide it by the term in front. So 20 divided by 4 gives us 5. Or you can just be really good at recognizing what you multiply by. So our common ratio here is 5. So my recursive equation is a sub n is equal to, what comes next?
A sub
n
n minus 1
plus 5.
times 5.
Times 5.
Sorry.
Good. And then, ooh, I forgot to write it. What do I always need to state for recursive?
Oh, A1. Yeah. A1 and then the ratio.
A sub 1, what your first term's value is. So in this sequence, our first term's value is 4. I need to state that because if I don't, I would have no idea where my starting point is. I would have no idea how to create any of the terms in this sequence. Now explicit. All I need to do is take a sub n, set it equal to a sub 1, which we just learned was 4, times the common ratio raised to n minus 1. And I'm done. I do just want to ask you, what is the common ratio on the next one? 1/3. Good. We always are multiplying to get our common ratio.
Actually got all of it.
Any questions on geometric?